Alrighty, let's have a go at solving some problems using the cosine rule. So two hikers leave the same base camp C for different destinations. Olga travels 17 kilometers on a bearing of 70 degrees true before setting up a new camp for the night. Katrina hikes 14 kilometers on a bearing of south 50 degrees east before pitching her tent. How far apart are the hikers' new campsites? Round your answer to one decimal place. So let's draw a picture. So we have C, which is where they're starting, and Olga travels, if north is here, 70 degrees this way. So it's going to be on this bearing here. This is where Olga's going to camp to. So let's call that position O for Olga. And this here is 70 degrees. Alrighty. Katrina, on the other hand, is on a bearing of, and it takes 17 kilometers. So 17 kilometers. Alrighty, Katrina, on the other hand, goes from south 50 degrees to the east. So east is this way. So there's south 50 degrees to east on a journey of 14 kilometers, and that's where Katrina stops. Let's call that K. And it says, how far apart are the hikers' new campsites? So draw a line from one hiker to the other, and we want to find out this side right here. So we want to find out how far apart there is from O to K at side X. So one of the things I always like to do is get as much information as I can. Let's put the 17 kilometers on the line. Well, I really need to know this angle in here. Well, this whole north-south line is 180 degrees because it's 180 degrees to go from north to south. So that means angle C, the angle inside there, is going to be equal to 180 minus 70 minus 50, which is going to be 60 degrees is this angle in here. So what I like to do now, redraw the triangle, removing all of my scaffolding, and then try to solve. So I've got 60 degrees here, C, O, and K. Got X over here. And then I know that this is 17 kilometers, and I know this is 14 kilometers. Alrighty, so what can I do with this? Well, now we can just use the cosine rule, and I'll show you why. So if I label this K with an A and this O with a B, then I get little b, little a, and that means X is little c. And you'll notice that I don't have a pair of side angle, because if I had a pair of side and angle, I'd rather use the cosine rule. But unfortunately, I know this side, but not its angle, and I know this side, but not its angle, which means the only option is to use the cosine rule. And in this case, we're using the cosine rule to find a side. So c squared is equal to a squared plus b squared minus 2ab cosine c. And that's angle c. So x squared is equal to 17 squared plus 14 squared. Take 2 times 17 times 14 times cosine of, and the angle we were given is 60 degrees. We want to find x, so we're going to take the square root of both sides. Get 17 squared plus 14 squared. Take 2 times 17 times 14 times the cosine of 60. And that gives us the distance. So we get is 15.7162 ... but it says to round it to one decimal place. That's 0.7 kilometers. And we now know the answer to part A. Part B says, what is the true bearing of Olga from Katrina's position? So that means we want to find out what is the bearing And this is really important. The true bearing of Olga from Katrina's position. So starting from Katrina, what's the true bearing? Draw a north line. We want to find out this angle in here. Alrighty, and so we might go, okay, well, how do we do this? But again, redrawing the picture is going to help. So for part B, we've got Katrina down here, and I'm going to exaggerate it a little bit. Let's make Olga up here. Draw a north line straight up, and then have a little east line as well. And we want to work out this angle. That's the angle we want to find out. We know this is a right angle, and we know this side is 15.7 kilometers. So this is the picture we want to solve. But unfortunately, this doesn't look like it's enough information, because if this is the angle we want, we've got the adjacent, but we neither have the opposite nor the hypotenuse, nor if we wanted to do Pythagoras' theorem. Well, Pythagoras' theorems can find us sides, but we don't have two sides. So we're going to need to work out one of these lengths. And this becomes a bit of a decision. We either need to work out what this length is, or we need to work out what this length is. Well, this length is on the north line. So that's basically how far north we've gone. This one is on the east-west line, so that just tells us how far east or west these two are from each other. So let's look back at our picture and see if we can work it out. We're going to have to change our picture slightly, so I'm going to redraw it with all the information we need now. So on this picture here, you can see that we've actually got a fair bit of information. And the funny part is that this length here that we want to find is actually this length along this big triangle as well, because it is just the vertical distance these two places are from each other. Oh, I've actually drawn the picture slightly differently over here, so let me just fix that up. Alrighty, so what we want to do is we want to find this total length from here to here, but actually we can't work out either of those, but we can work out these ones, because that's a right angle and that's a right angle. And so what we're going to do is instead we're going to find this length and then this length separately. So it's called Y and Z. And then once we've got these lengths, then we can go through and add them together, and that's going to give us this total length here, which is the vertical distance, the north-south distance that K and O are from each other. So let's look at Y first. Well, according to Y, this is the hypotenuse and this angle 70. And this is the adjacent according to that angle 70. So we're going to be using cosine. So cos theta equals A over H. Cos 70 equals adjacent, which is Y, over hypotenuse, which is 17. Multiply both sides by 17, and we get 17 times cosine 70 equals Y. Y is equal to 5.81 kilometers. So that's how far north Olga went. Let's do the same thing for Katrina. So for Katrina, her triangle, well, this would still be the hypotenuse, the 14, and the adjacent, because we've got the 50 degrees here, this would be the adjacent Z. So let's do the same thing. So cos theta equals adjacent over hypotenuse. Cos 50 equals Z over 14. Times both sides by 14, we get 14 times cos of 50, which we type into our calculator, which gives us the value of Z. 8.999, which rounding to two decimal places would be 9.00 kilometers. So we now know the total distance from here to here, which is just Y plus Z, which is 5.81 plus 9.00 equals 14.81 kilometers. And we now have enough information to find this angle. So let's label everything. according to this angle, this would be the hypotenuse, and this would also be the adjacent, so we're going to be using cos again. So we get cos of theta is equal to A over H. Cos of theta is equal to 14.81 over 15.7. Move cos to the other side. Theta is equal to cos negative 1 of 14.81 over 15.7. And therefore theta is equal to 19.384 ... and it wanted it to the nearest degree, so I can round that to 19 degrees. But it also wanted it to actually be a bearing. So just having a look back at the picture, that actually already is the bearing. So the answer is going to be 19 degrees true from Katrina to Olga. And that is the end of the question. Quite a tricky one, especially that part B, but part A, not so bad. See you in the next one. Goodbye.